Hello everyone, I'm audible. Yeah. Okay. So good evening everyone. Welcome to Machine Learning Day 7 by GDG Jalandhar on the event called Tech Drill. My name is Ravi Rana and I'm your mentor for this particular event. So yesterday we talked about classification. What classification is and what are the different, can you please repeat about project? We'll talk about it today, Sushant. We'll talk about project today. So we talked about we talked about what is classification, what are various types of classification, what are the various algorithms used for classifications, and we saw this KNNs in depth. We saw KNN in depth. Okay. So now let's go back and we will be working. We will be seeing how we will evaluate our data set, how we will be evaluating our KNN model. Okay, so and we will be seeing the sklearn implementation of KNN. We will be seeing how KNN is implemented. Okay, so let's start. Just give me 1 minute. So now we will be seeing how we will evaluate our classification models. So for our purposes of this, for purposes of the evaluation of a so we had accuracy score, we had we had something called this RMSC, the MSC, mean squared error, root mean squared error. So how we evaluate these, how we evaluate our classification model. So first of all, what do we do for evaluation of this classification model? First of all, we make a confusion matrix. So please pay attention to it. Please don't talk about projects right now. Please don't talk about any project. Please don't talk about any other thing. Why? Just please pay attention to these matrices, because for that, because as its name is confusion matrix, it can be really confusing. It can really be confusing if you do not get the hang of it for the first time. Okay, so now what is the confusion matrix? So confusion matrix is just a sort of a table that we use to describe the performance of our classification model. Because why do we need a confusion matrix? Is that you have made a classification model, you have made suppose you have made a classification model for classifying the images of cats and dogs. So but now you also need to know that how much accurate this model is. So for that purposes we have many matrices for this calculation, and to sum up those all matrices we make a confusion matrix. So what is a confusion matrix? Confusion matrix is a sort of table. So as you can see on the screen right now, we have 4 types of values in our confusion matrix: data, true negative, false negatives, false positives, and true positives. So what are actually these values? Okay, so true, suppose your model is used to predict images of cats and dogs. So wherever I'm going to take this consistent example of cat and dogs throughout today's class. Throughout today's class, I'm going to take a consistent example of this of the cats and dogs model. Okay. So what is this confusion? So now in our model, in our machine learning model, that we have made a classification model to predict the difference between the image of a cat and dog. What do we have? we have something called true positives. So suppose you have trained your model, you have trained a data set which contained images of cats and dogs, which contained images of cat and cats, which contained images of dogs. Okay, so now what happens? So now what happens is that there called positive true positives. That is are actually the values that you predicted. Yes. So suppose there was an image of a cat, and while testing your training data, while testing your machine learning model, your machine image of cat. So that is true positive. Okay. So now you have another image. You have a second image, and that is true positive. And now, but at suppose you have and it is correct. So they may so that is value is actually called and are also called as type 1 error. And false negatives is that we predicted okay, thank you, Rohit. Any other, if you have any problem, you can state. So confused. So Mayur, can you please tell me where are you confused and what values are you confused? True negative and false negative. Okay. So now let's say you have a machine learning model that predict you have two classes, okay, class one and class two. And let give up on the example of cat and dog, and let's take as an example of yeses and nos. You have those two class contains a yes and a no. Okay, so now you have a yes value and a no value. So suppose what is a true negative value is that machine learning model your machine learning model correctly predicted your machine learning model correctly predicted your value that the yes is not belonging to the no class. Okay, so you predicted at it as that it does not belong to this class, it belongs to that class. So that is a true negative value, that is truly doesn't belong to class 1. Okay, and error, it is a type of for error which is called as type 2 error and is called as false negatives. Okay, so are we clear now with false negatives and false positives? Okay, so do we have any other problem? So shall we proceed? Okay. So now what is the evaluation criteria? So now we have made the confusion matrix. We got all our true negative values, we got all our false negatives value, we got all our false positives and true positives. Okay. So now how do we utilize these four values? How do we utilize these four values to predict actually evaluate our machine learning model? And to do that, we have several evaluation criteria. So first and foremost is called the accuracy. So accuracy is the most simplest way to describe the to evaluate our classification model. Okay. So now accuracy does gives you the actual prediction. So suppose you have a data set, you have a balanced data set. What do you mean by balanced data set? That both two classes, the class 1 and class 2 are in equal numbers. There is 50-50 distribution of both of these classes. So now there we use accuracy. For that evaluation of that type of data, we use accuracy. So now for how accuracy is being calculated, so how accuracy is being calculated, for that we use I will show you the mathematical formula for accuracy, and how do we get it. So let's jump onto our whiteboard. Is my board visible? So let me just clear it. So now what is accuracy and how it is calculated? So accuracy is predicted as will be defining accuracy as ACC, that all the true positives and true negatives divided by sum of all these values. All the true positive, true negatives plus false positives and false negatives. That all of these. So I will making a all values. Okay. So can you please repeat confusion matrix? So what is confusion matrix? So Karthik, okay, so let me repeat it. Otherwise, you will not the whole session would not be of but confusion matrix. Just let me share the screen. Classification learning model. What do we do in confusion? So what is it? It belongs to, and your machine learning model actually so now we predicted that this data point belonged to class 1. Okay, but it actually belonged to class 2. So we predicted it as a yes. So this is called a false positive value. So now similarly, what is a false negative value is that we predicted a data point that it does not belong to class 1, but it actually belonged to class 1. So this is called a false negative value. So hope I'm clear, Karthik, with confusion matrix. Okay, great. So just let me quickly get back to the Jamboard. And so now for evaluation of balanced data set, we have this thing, we have accuracy. So what is accuracy? Accuracy is a type of metrics which is used when we have a balanced data set. So suppose you have a data set that contains 50-50 some of all the true positives and some of all the true negatives. So what does it means? That all the actually predicted yes values and all the actually predicted no values upon sum of all the actually predicted yes and wrongfully predicted yes values, and similarly the actually predicted uh, and the false positives and the false negatives, the true positive, true negatives, and the false negative, false negatives. So now what we do is that the false decision that out of all the positives, that out of all the correctly predicted values, the values which are actually predicted, which are actually positive. So now let me make it more clear. So suppose we had the data set and we predicted that all the actually predicted values it is called specificity. So what is specificity is, so just as we predicted precision, that is the actually predicted true values for all of the true values. So now specificity is actually predicted actual negative values from all of the negative values. So for how it is calculated is that the actually predicted negative values are called true negatives, and the all total negatives values are true negatives, the sum of true negatives and false positives. So let us understand what this formula states is the true negatives are the actual negative values, and and now what the false positives are the values which was said that it belonged to class 1, but actually it belonged to class 2. So it is a negative value. So specificity is all the true negative values that was classified as actually negative divided by all of the negative values in our data set. Okay, so is specificity clear? Is specificity clear? Okay, so now what is F1 score? So now we will talk about F1 score. What is F1 score and how it is predicted? So F1 score is actually a matrix. That is used to predict. That is a measure of that is actually made a measure of a model's accuracy, and it is actually a mathematical formula which is given by the precision and recall of the data set. So we had seen what precision is and what recall is, what precision is. So what was precision? Precision was the actual positive value that our model predicted as actual positives to the total positives values. And what was recall is that what the total corrected value, the total correctly predicted values. Okay, so now how this F1 score is calculated? F1 score is just a mathematical formula, and how F1 score is calculated is that F1 score is equal to twice into precision into recall divided by precision plus recall. Okay, so this is called your F1 score. So F1 score is nothing but a mathematical formula. This is nothing but a mathematical formula that gives you that what is your, so how accurate your model is, how correctly your model is predicting. Okay, and it is given by this precision and recall. This is given by a formula of the precision and recall. Okay, so is F1 score clear? Is F1 score clear? How we calculate F1 score? And F1 score is nothing but just a evaluation parameter that is combined of recall, that is the combination of recall and precision. So is now F1 score clear? Okay, so now jumping back to our slides. So now what we have something called an ROC curve, ROC and AUC. What is ROC and AUC? So ROC curve is also called a receive operating characteristic curve. Receive, what does it shows? So ROC is made of is evaluated. The ROC curve as given by our model is evaluated using the true positivity rate and the false positivity rate. So what is the true positivity rate? That the actual predicted, the true and the positives, the actual predicted positives. Okay, just you can call it as recall. So our ROC curve is given by the recall against our against this false positivity rate, that how many false positives we got from our total number of negatives, or in the total number of negatives. Okay, so is true positivity rate and false positivity rate clear? Is true positivity rate and false positivity rate clear? Please, can you clear it in the comment section? The true positivity rate is nothing but the recall value, and it gives you the total correctly predicted value, and false positivity rate is nothing but the value which gives it a total of falsely predicted values. Okay, so now we plot a curve under it. So now we plot a curve for the true positive values and the false positive values, the correctly positive predicted values and the wrongfully predicted positive values. We get we plot a curve under it, we plot a curve for it. Okay, and this is called the ROC curve. And what is the AUC? AUC stands for area under the ROC curve. So AUC stands for area under the ROC curve. So what does it mean? That is the entire, you should measure the entire two-dimensional area under the AUC curve. So now, as you have seen, that we have this line. So if your curved region is, the area under the curved region is greater than this line, the more area under the curve, the better is your model. So to summarize what we have learned till now is that we make a machine learning, we make a curve for the true positivity rate and false positive rate. Okay, for the true positive rate and the false positive rate, and you make a curve under it, and the area under that curve is called the AUC or area under the curve simply. And now, if more the value of AUC, the better your machine learning model is, your better your classification model is performing. So is ROC and AUC is clear? Please, a yes or no. Okay, so now that was a lot of maths. That was actually a lot of mathematics. Now, what do we, let's summarize what all these formulas were. So the formula of the accuracy, you can see here, the sum of the two true positive and true negatives upon total or upon every matrix, and the precision, the actual correctly predicted values upon the total positive values, and the recall or sensitivity is recall or sensitivity totally created TP upon TP plus Fn. The specificity is also calculated as 1 minus a false positivity rate. Okay, and that is calculated by Tn upon Tn plus Fp. And the F1 score is calculated as 2 into precision into recall upon precision plus recall. So this was the summary of all of this mathematical part. So the evaluation matrices are clear. Okay, so now let's see how KNN model works, how this KNN classifier works. So instead of writing a whole model for it, because I have not written the whole model for it, because for that we had to perform the ED exploratory data analysis, the feature engineering and the feature selection. But we have performed it for the past 3-4 days, and I feel quite comfortable that you guys are able to do that on your own. Okay, so now let me share the official sklearn's documentation for it. So why the official sklearn documentation? Is just because, as I said earlier, you can see the code in the sklearn class, sklearn documentation. You can learn the code anywhere, just important theoretical concept matters. So now we have covered all the theoretical concepts. Let's just see that how this KNN classifier can be used by the help of the sklearn library, and what better way to understanding the use of this sklearn library is in the documentation. So now we had, for using the sklearn k-neighbors classifier, you have a, it is present under sklearn.neighbors.kneighbors classifier. So let's see the for example, from sklearn.neighbors we will import our k-neighbors classifier. Okay, so now, as someone pointed out yesterday, is that how we used KNN model, for how we used our KNN algorithm for regression purposes. So now for that we have several X values, training data, our features, and it is 0, 1, 2, 3. And for that, and for our target values is y is equal to 0, 0, 1, 1. So now we will import from sklearn.neighbors, import k-neighbors classifier, and we will be making an object of it. We will be making an object for it, and we will initialize the object as k-neighbors classifier, and number of neighbors is equal to 3. So what is n neighbors? What n neighbors means here? N neighbors means the k value, the how many nearest point values do you need, and you will fit this x and y over this object for this object. And now we will use the k neighbors dot predict for point 1.1, because it has been trained for, we see that for 0 it gives answer 0, for 1 it gives answer 0, for 2 it gives answer 1, and for 3 it will gives us answer 1. So now we will be seeing what answer does it gives for 1.1. So now what we do, we will be using NEH.predict for 1.1. What will be the answer? The answer would be 0. The predicted value is 0. Okay. So now it has also shown us the use of probability estimates. Learn about probability. Read about probability estimates on your own time. Just explore it. Okay. Just explore about this. Learn about probability. What are the probability estimates and how those are calculated? It's just another statistical term. So now let us see how this is used for this classification purposes, how this model is used for classification purposes. So now we have something called sample is 0, 0.0, 0, 0.0. These three classes we have these three classes, and we will be importing from sklearn. Similarly, we will be importing from sklearn.neighbors, import nearest neighbors, and we will be making an object where k is set to 1. Okay, so now we will be fitting all of those samples in this neighbor class. We will all be fitting all these three classes in this neighbors object using the function of dot fit. And now you will see that now we will be using NEH, the NEIH, our object, and we will be fitting k neighbors for 1, 1, and 1. So we had three classes: 0, 0, 0, 0, 0.5, 0, and 1, 1.5. So now our array gives us answer 0.5 and 2. So, and we have used k neighbors for it. So what does k neighbors give us? It gives us the distance 0.5 and is the third element of the sample, and 0.5 and 2, which means that the element is at distance 0.5. That this element is at a distance of 0.5, is at a distance of 0.5 from the Euclidean distance of 0.5, and is the third element of the samples. That is the third element of the samples, that it belongs to this class, because array 2 gives us 0, 1, 2. This 2 gives us, this is the third element of it, is the third, it belongs to the third class. Okay, so you can also be making the graph for it. So this is how you use k neighbors for your prediction and for your regression and classification. So now get ready your data using the EDAs and the feature engineering. Get ready your data. algorithms, apply the various types of algorithms on it, apply KNNs, apply SNNs, apply different algorithms, and also, if possible, share your work with me. So now, jumping back to the slide. So now let's talk about your favorite topic, the project. That what do you need to receive the certificate? What do you need to receive this certificate? Okay, so many of you were when you wanted to talk about the project. So now you will be getting a Google form in your emails. You will be getting a Google form in your emails, and in that you will have these four in the link for these four data sets. You will be having a link for the car price prediction data set. You will be having of a link of the heart disease prediction data set, and for similarly for Titanic survival detection and fake currency detection. Okay, so you will be having these four link for these four data sets, and you will just make your model, make your regression model, make your classification model. You can take help from various online sources. You can take help from various GitHub repositories are available where you can see the code. Just not blatantly copy the code. Just not blatantly copy the code from those GitHub repositories. You can take help, get intuitive, get imaginative, work on these four projects. They are most commonly used projects, and make a collaboratory notebook. And if you are working with 3 to 4 notebook, no problem, paste those 3 to 4 links here, okay, in the Google form. So now just make sure you make it publicly shareable, that the link is publicly shareable, and submit the project by 10th of July. You have ample time. You have the time for the project submission on 10th of July, and please share the Google Colab link. The submission form will always be shared on our Discord channel and also in your respective email IDs. So 10th of July. Sorry. It is a goof up from my side. It is a goof up from my side. 10th of August, please. Sorry. 10th of August. Sorry. Let me be clear. 10th August. August 10th. Okay. Sorry. So now, thanking you. My name is Ravi Rana. Thanking you for these 7 wonderful days. And if connect with me over LinkedIn, connect with me over Twitter, connect me over various sections. Where to share the link? You will be getting a Google form link. You will be getting a Google form link in your email ID in your in the Discord channel. Okay, so share the link. You share your collaborative notebooks there, and as I've earlier told, it will contain 3 theoretical questions. Just answer it in 20 to 40 words. I've been clear about it. So this was about project. So thank you for being there. Thank